So here we go. Let's do some speed problems. Let me focus this a little bit better. Look. Hello. There you go. There you are. Okay. Using the 5-part problem solving method, let's write down what we know. We'll calculate the average speed. So that's what we're looking for. We'll just put it down like that. In meters per second of an ostrich that runs 800 meters north. So that's a distance. And how do you know it's a distance? Because meters is a unit of distance. And then the ostrich does that in 12 seconds, so that's the time. So you only have one formula that you're working with so far, so I guess that's got to be the one, S equals D over T. And then you're just going to plug into that formula. So S, which is what we're looking for, equals 800 divided by 12, which is our time. So when we do the math out, we end up with 66.67, remember rounding appropriately. And we got to put a unit on here, meters per second, because that's the speed unit. Okay, next, let's see if I can slide that underneath there so you can see it. Calculate the average speed in meters per second of Mario, who runs, so we're looking for speed again. He runs up the 4-meter ramp, so that's a distance, equals 4 meters. To save Princess Peach, it takes him 5 seconds, so that's a time, equals 5 seconds. Again, same formula. And we're going to plug into that formula, S equals 4 divided by 5. When we do that out, we get 0.8 meters per second. Okay, so far, so good, not too bad. Do the next one. The next one actually asks us to use information what we calculated in the previous one. So calculate the distance. So we're looking for distance. That if Mario runs, if he maintains the average speed. So this is our average speed from before. So that's our speed that we're going to use, meters per second. And for 60 seconds, so that's time equals 60 seconds. Notice as I was reading the problem, every time I ran into a number or something, for all of these problems, I wrote down what it was in the known formula. That way, so if you are reading the problem and you're like, oh my God, I don't know what to do, if you just take it a little bit at a time, it'll be okay. So we're going to use the exact same formula again. And this time, we're going to do 0.8 equals distance, which is what we're looking for, divided by 60. Now, there's a couple of ways that you can attack this. I'm going to teach you the Bovin Ninja way. You can multiply these two things together, and if you put a 1 underneath that number, it doesn't actually change anything. And then multiply those two things together and set them equal to each other. So you get 0.8 times 60 equals 1 times D. So multiplying 0.8 times 60, you get 48, and the unit for that is meters. Okay. Next one is we're going to calculate the time in seconds. So that's what we're looking for. It says a car will travel 3,500 meters, so meters is a distance. So we're going to write that down. And then the speed of the car is 25 meters per second. Okay? Only got one formula, so we got to write it in there. And we're going to put the work down. So we got 25 equals 3,500 divided by T. And we can still use the little ninja math move that I showed you in the last problem. It's just we got to do something afterwards. So we got 25T equals 3,500. Now, in your math class, you probably had to figure out how to get the T by itself, and it's really easy. All you have to do is divide both sides by 25, which is the number next to the T. So that divides out. So 3,500 divided by 25 is 140. And what is it we were looking for? Oh, time. So time must be in seconds. Okay, so that's the first 3. Let me flip the paper on you here. And then the next one is calculate the distance. So distance is what we're looking for. A bicycle will travel in 12.5 seconds. That's a time. if its speed is 9.4 meters per second. Okay, same formula, S equals D over T. And so let's plug in 9.4 equals distance, which is what we're looking for, divided by 12.5. So again, we're going to put a 1 underneath there. It doesn't change a thing. We're going to multiply these two things together and set it equal to those two things multiplied together. So D equals 9.5 times 12.5 and do 66.6. And we were looking for a distance, so that's meters. Okay, the next problem is a little bit different. It's only in the fact that we're using a different letter here. You probably remember that speed and velocity are basically the same thing, except velocity requires a direction. So we're looking for the velocity of something, of a skateboarder that travels a distance of 32.9 meters west, and we'll just write that in there. And the time that it took them to do it is 7 seconds. So instead of S equals D divided by T, now we're going to use V equals D over T. Same formula, we just substitute the velocity for the speed. So we got V equals 32.9 divided by 7. Do that out, you get some number. Oh, I'm sorry, I made a mistake up here. So sorry, I forgot to flip my paper over. 7.5 meters. So number 4 is 7.5 meters, 117.5 meters. Sorry about that if you were like freaking out there. When you divide these two things, it's 4.7 meters per second, but because we're looking for a velocity, we have to put a unit direction on that, and that would just be west. It's really important that you put the direction there, because without it, it's not really a velocity. Okay, last question. Calculate the time. So we're going to put time over here with a question mark. Takes a horseshoe to travel a distance of 10.3 meters if it's thrown with a velocity of 3.1 meters per second west. A lot of stuff going west here. So same formula, velocity equals distance divided by time. Going to plug into that formula, 3.1 equals 10.3 divided by T. Going to do that ninja math move there. And we're going to say 10.3 equals 3.1 times T. Awesome. And so we're going to divide both sides by 3.1 so that we get the T all by itself, because those two things go away. And we end up with an answer of 3.32 seconds. Okay, so that's all 6 of those problems. Hope that kind of helped explain what was going on there. Thanks for watching. Have a great day.